You know those videos we can't stop watching? I overdosed on butter and eggs, and this is what happened to my body.
This is 300 eggs. It's only gonna last me 10 days because I'm gonna eat 30 eggs a day for 30 days.
1 stick of butter, 30 days straight, every single day. And actually most of those days, I was eating a lot more than 1 stick of butter.
So for the last 30 days, I've been eating eggs and raw milk only.
I'm going to the lab to get my blood drawn. Then I'm going to eat 100 eggs in 7 days. So my total cholesterol went from 207 to 277. So that is about the same. My LDL went from 136 to 201, and that is also about the same.
What if a whole team of scientists were on the job with their fancy instruments to observe and to interpret the results? Even better, what if the scientists were able to lock 20 people up for 30 days and put them on the 2 most controversial diets, low-fat vegan and keto? The first question I'd have is, what flavor of vegan? There's a very prominent group of scientists and doctors with best-selling books who favor very low-fat vegan. And a second group who are stirring it up on vegan Twitter saying, oh, come on, avocados and olive oil never hurt anyone. I don't have a horse in that race, but it does remind me of a favorite t-shirt I own. But I am glad that the scientists who really did lock up 20 people for 30 days chose the lowest fat version of a vegan diet, because they also chose the highest fat version of a low-carb diet, keto. So we had the 2 extremes of fat head-to-head. And so we also got 0 animal foods against a lot of animal foods. Fascinating. Here's what the meals looked like. The way it worked is each participant had to be locked up at the National Institutes of Health for a month. I sent a draft of this episode to Kevin Hall at the NIH for fact-checking, and he said, hey, we don't lock people up. They can end their participation in the study anytime they want, and we even allow them to walk outside if they're accompanied by a member of the research team. I guess that's to guard against them sneaking off to 7-Eleven to get a Snickers.
Snickers satisfies.
Anyway, I apologize, Kevin. That was just my crazy sense of humor.
Mom always said your sense of humor would get you in trouble.
Okay, back to the episode. Eating one diet as much as they wanted to eat for 14 days, and then the other diet for 14 more. And they had to be subject to a battery of tests. When 12-year-old Caitlin heard that, she said,
what? Who would do that? 30 days stuck in a boring hospital room?
When I told her the volunteers got paid $5,200 if they did all the things, she said,
$5,200? Wow! Sign me up! I would definitely do that!
Since both diets have been promoted for weight loss, this study was focused on how many calories do people eat and how much weight do they gain or they lose when they're able to eat as much as they want on either diet. But they also measured things like blood sugar, insulin, and cholesterol, yellow flags for diabetes and heart disease. And I was quite surprised to see how dramatic the differences in blood tests were on each diet after just a few days on each one. This is the paper published in Nature Medicine. Ad libitum is a fancy term that means you can pig out if you want. True confession, I am a scientist and my heroes are great scientists, but I really dislike the language that scientists use. I did a crazy stint at Barnes & Noble, and they had me work on the relationship between the best-selling authors of the day. Stephen King, John Grisham, Michael Crichton, and Tom Clancy. So I spent hours with their agents. Grisham's agent told me those authors shared a dictionary of 7,000 words that consumers all understood the same way. I think there is often a large gap between what scientists think they're saying and what people actually hear. There's actually a great book about that, which you may love to hate because it's written by political operative Frank Luntz. Words that work. It's not what you say, it's what people hear. He is the master of focus groups to figure that out. I have never seen a field like nutrition where the language is so unclear, where companies have successfully associated their products with words. For example, I think most people hear meat when scientists say protein, and they associate it with muscles. And they hear all plants, including beans and fruit, when someone says carbs, and they associate that word with diabetes. I think of genius marketing from the meat and dairy councils when I hear those associations.
Ladies, gotta go to work.
Thinking I know something about writing, I rolled my eyes when I saw the line that read, "Weak effect on satiation and satiety." And I thought, oh, come on, is that from the Department of Redundancy Department? Surely those two words are synonyms. But I also believe that to really understand a paper like this, I need to talk to one of the authors. So I dialed up lead author Kevin Hall, and I got a humbling when I asked him about satiety.
I don't know what it is about dried jackfruit, but to me it's like a candy bar. And I'll just eat handfuls of it. What do you say when people say it's all about satiety per calorie?
Now, when you say satiety, I have to push back and say that has a very specific meaning in appetite science. It means like the feeling of fullness between meals that either delays your next meal or makes you eat less at the next meal, as opposed to satiation, which means how much you eat in a given meal. So is your jackfruit example, are you talking about the fact that when you sit down and you have a big pile of jackfruit in front of you, you can't stop eating them? Or are you saying, which is satiation?
Yes.
So you're saying satiation per calorie is what you really mean. Which
Oh,
is
I see.
The ability
that's
to stop eating that food and how much you've eaten in a given meal. Formally, those are different parts of appetite. And then there's hunger, which is how you feel before you start eating. So there's various parts of appetite regulation and control.
Uh-oh, I just got owned for not being clear about the definition of those two terms. So I paid $150 for this book on satiety, and it opened up a whole new world of things I never knew to help me understand this paper. For example, about the hardness of food. People ate less of a realistic meal with harder textures compared to the same meal with softer textures of the same foods. And subjects did not compensate for the difference in energy intake between the hard and soft lunch later in the day. What? Am I the only one who didn't know that? Practical tip. There were a dozen things in this book like that I didn't know. How do flavors, smells, and the variety of foods on the plate affect satiety? Dramatically, it turns out. You may be asking, why is Chris going off on this tangent? Why doesn't he get on with the results of this paper already? 2 reasons. Our professors in grad school used to tell us, focus on the papers that really matter. Bring as much knowledge to them as you can. That will mean less time for lesser papers, but it doesn't matter. They're mostly noise anyway. Second, I believe the knowledge of scientists who lead these studies is the most important thing, more important than the type of study even. I want to know that career scientists who completely understand these influences kept them in mind when designing the study and interpreting the results. I've spent many days of my life studying Kevin's papers and have come to believe he's vastly more knowledgeable than any of the YouTube influencers whose clips I showed. On to the surprising results. First, the participants rated the meals to be about the same on average in terms of hunger, satisfaction, fullness, and eating capacity. Although you can see from the scattered points there must have been considerable differences of opinion among the participants. Second, the average calorie consumption was considerably higher when on the low-carb diet, about 550 calories a day. We often hear chatter on the internet that high-fat meals are more satiating, so this may be a surprise to some people. But my $150 satiety book repeatedly lists fat as being the least satiating nutrient behind protein and carbohydrates.
I didn't expect to see such a caloric difference between the two diets. Now, it decreased in the second week, right?
And we specifically designed the study to look at the overall effects over 2 weeks and then the last week separately. And we pre-specified that because we thought that on the low-carb diet, it's going to take a little time for ketones to build up in the blood. And we saw that, within 3 days, they go into a state of nutritional ketosis. But after the first week, sort of ketone levels in the blood have sort of stabilized. They might be climbing very slightly, but non-significantly thereafter. So we thought that that second week, we would have probably seen the effects of ketones, which people had hypothesized in the past as being a sort of appetite suppressant. We suspected that on the low carb diet, that energy intake might decline a little bit on the second week, and it did. But they were still about 550 calories per day higher than the same people on the second week of the low-fat diet.
But the weight loss was higher during the 2 weeks on the low-carb diet. That did not surprise me because, as I've shown in past episodes, nothing beats a low-carb diet for quick weight loss. It's a tortoise and the hare story where low-carb diets work right away, whereas you can see the low-fat diet took almost a week for results to show up and 2 before it started to close in. But the great advantage to a rigorous study like this as opposed to lone YouTubers is you can tell exactly where the weight loss is coming from. In the case of the low-fat diet, it was coming from body fat. In the case of the low-carb diet, it was coming from muscle and water weight. You wouldn't know that looking at your scale at home. I had read other rigorous studies comparing a low-carb versus Mediterranean diet. And there too, the low-carb diet jumped out to a big lead in weight loss. But they were even after a year, and the Mediterranean diet pulled ahead after several years. So why did more people consume more calories on the low-carb diet? Kevin co-authored a paper later saying that caloric density of the food and eating rate are factors across 4 dietary patterns, including keto. In this study, the keto diet had twice the caloric density per gram, and they measured eating rates. 31 calories per minute for low fat versus 42 for keto. One curious observation is that while eating the keto diet, resting metabolic rate was 160 calories a day higher. I asked Kevin about that in an email, and he said it was probably because of their higher caloric intake. Now for the blood work. I have never seen so many measurements. Do you have time for an 8-hour episode? I didn't think so, so we'll just focus on cholesterol and blood sugar. There are a lot of seriously crazy and hard to understand theories about cholesterol on the internet from people like Sten Ekberg, a chiropractor not involved in heart disease research. This is very personal to me because I've lost way too many friends starting in their late 30s because they didn't know how simple the basics are and how grave the risks are. I'm going to give the very simple explanation, but if you want the whole story, the king of cutting through the fog of internet misinformation about cholesterol is Dr. Carvalho. A blood test called ApoB is the gold standard of heart disease risk prediction. In this study, the 20 patients entered with median ApoB levels of 73.5, which is very good. Most organizations would say less than 90 is optimal, less than 80 if you have other cardiovascular risk factors. 2 weeks on the low-carb diet pushed it up 3.5 points to 77, still good. 2 weeks on the plant-based diet dropped it 16 points to 57.5, which is excellent. But you probably don't know your ApoB because it's an uncommon test, and I shouldn't be such a scientist. Lucky for us all, a very close approximation is non-HDL cholesterol. You already know your total cholesterol and your HDL. Just subtract HDL from the total and voila, 97% concordance with ApoB. The median for the participants for non-HDL when they entered this trial was 108. After 2 weeks on low carb, it went up to 114. After 2 weeks on low fat, it dropped to 83, 25 points lower. That's a lot. Here's what the risk profiles look like over 30 years for different levels of non-HDL. The lowest line in red is below 100. The plant-based group fell on that line. The low-carb group landed on the second line, considerably higher risk. Sten Ekberg fell on the third line before he ate the 100 eggs, which is about double the risk of the bottom line. After 7 days of eating all those eggs, Sten fell perilously close to the top line at 212, which represents extreme risk, 4 times the bottom line, nearly a 50% risk over 30 years. The slope of those lines increase or decrease with age, smoking, exercise, etc.
What do people who are good science communicators typically do, even if it's on social media? They'll rarely discuss things in absolutes. The only thing that I would come across as very absolutist on is LDL cholesterol and heart disease. I'm at a point now where I'm comfortable enough with that evidence to be like, this will put plaque in your arteries.
And now for blood sugar. I have wondered about a simple question for a very long time, and this study connected a fascinating dot for me. And the question is, if we are showing symptoms of type 2 diabetes and we eat foods that completely flatten our glucose curves, does that put our type 2 diabetes into remission? Or is it like a pain pill that just masks the symptoms? If you can never eat another bowl of fruit again, is your type 2 diabetes really in remission? The volunteers in this study were screened to exclude type 2 diabetics, and here's what their glucose curves looked like. The low-carb group hovered around 76 before a meal, and it rose modestly to about 82 after. The low-fat group started at 83, and it peaked at about 115 an hour after the meal. That's a dramatic difference. Is it unhealthy at 120, or do we not enter the danger zone until it hits 140? What if you were to eat foods that completely flatten your glucose curve, and then you did an oral glucose tolerance test where you drank a big glass of sugar water? Would it show that your glucose tolerance had improved? They did perform glucose tolerance tests on the volunteers after each 14-day diet period, and they found the low-carb diet resulted in a relative impairment of glucose tolerance compared to the low-fat diet. Mean glucose during the oral glucose test was 115 with the low-fat diet compared to 143 with the low-carb diet. Yikes, maybe that reveals a gap in my knowledge, but I did not see that coming. So if you're not diabetic and you adopt a keto diet for just 14 days, you could see a diabetic spike of over 140 if you eat a slice of cake at your child's birthday party, but you probably wouldn't if you were eating carbs. No problem, that's fine. Is the pancreas like a muscle where you use it or lose it?
It's kind of part of the lore of low-carb diets and ketogenic diets is if you're going to go for an oral glucose tolerance test, you've got to wean yourself off of your keto-adapted state. Otherwise, you're going to look like you're glucose intolerant. And that's exactly what we saw at the end of this period of time. We gave people a glucose tolerance test, and it was much worse after the ketogenic diet. We don't think it's because they became insulin resistant. We think it's probably because their beta cells are just not used to secreting insulin. They just have been adapted to this high-fat, low-carb intake, and the body's amazing, right? If you basically tell it that you don't really need to process too many carbs, it gets used to that. And I'm sure that there would be a period of time not too long thereafter of reintroducing a higher carbohydrate diet because, in fact, half of our subjects did exactly that. And you give them a glucose tolerance test and they're perfectly fine.
Doesn't that make you wonder what happens if you don't do this for just 14 days, but you do it for 10, 20, or 30 years? Maybe the pancreas just chills for 30 years and springs back to normal after being summoned by carbs. Or maybe eating reasonable carbs like beans and fruit keeps the pancreas healthy for 100 years as populations all over the world have observed. What if the pancreas goes the way of our muscles, bones, and brain if we don't use those either? The thing is, I don't think we know that answer, do we?
I was low carb for 7 years as a type 1 diabetic and had fantastic results, like really, really nice, stable blood glucose control, pretty good insulin sensitivity. I took it to the extreme. I went keto for about 4 months. The first 2 months, even better results, like flatlined blood glucose, very low insulin levels. And then I ran into a proper hurdle where my hepatic glucose output overnight, my fasting glucose in the morning was just on its way up. Day after day, week after week, month after month. I was actually such a keto lover at the time that I couldn't let go. My conclusion, as you've probably read in my writing, was that I'd lost glucose tolerance. I think that long term, and this is, I've received hundreds of messages from people in the same position as me who are living with type 1 diabetes, did keto long term, ran into the same hurdles.
Here's one reason this question bothers me. For thousands of years, we've had young doctors passionately argue for high animal food diets, and we have some today. They can look like the model of health when they're young, and many have patients who've done well on their diets for maybe 10 or 20 years. But when you ask how many people can thrive on a diet like that for many decades, into their 70s, 80s, and 90s, the answer that frequently comes back is, well, Dr. Bernstein has been on a keto diet for 50 years and he's 88. The thing is, we have many studies of populations who eat modest amounts of animal foods and live very long and thrive. We've had high animal food diets for a long time. They're very popular, and yet we fall back on anecdotes and outliers. I haven't found large, well-studied populations of people who have genetics like ours who lived long and thrived on high animal food diets that we can point to. And that brings up a great question. Do we have quality long-term studies that can complement this very short-term study? Long-term studies reveal very different things than short-term studies, and taken together, all kinds of fascinating insights emerge. For example, Herman Ponzer is a talented paleoanthropologist who's done very high-quality studies. Arctic cultures like the Inuit have lived for 8,000 years on a diet that would put us into ketosis, and here's what he said in one of his books about them.
Arctic populations have also adapted to eating a lot of meat. These populations are often held up by Finney and others as great examples of the benefits of a ketogenic diet. But remarkably, most people in these groups can't go into ketosis. Instead, they carry a mutant variant of the gene CPT1A that essentially prevents the production of ketones. The non-ketogenic variant was so advantageous among the Inuit and other Arctic cultures that it is ubiquitous among these populations today. Paleo dieters often expound upon the advantages and antiquity of a high-fat, ketogenic diet, but in the populations who have actually lived with these diets for generations, natural selection has pushed back hard.
So what are my takeaways from this episode? Number one, It's a great paper. I think if you read it quickly without a complement of other papers to look at, you'd look at that weight loss curve and the flattening of the glucose curve, and you'd say, whoa, keto for the win, for sure. But if you're fully OCD like me, you'd look at those blood tests, including a few I didn't mention, and say, that's not particularly a good look for keto. And you'd seek out other studies and you'd say, ooh, this really isn't looking good. For example, Kevin's study did not touch on neurology, and none of the YouTubers I cited earlier would have any idea what's happening to their brains when they ate 100 eggs in 7 days. But here's a talented scientist who devotes her career to that, and this is what she said in her book.
You might have heard of ketone bodies if you've ever been on certain low-carb diets. One in particular is called the ketogenic or keto diet, and it is a neuronutritionist's nightmare. It is high in saturated fat and very low in carbohydrates and fiber, which forces the liver to burn all available sugars before turning to fat to stabilize blood sugar levels. While it is true that the brain can use ketones in place of glucose, this is the exception, not the rule. Burning ketones instead of glucose is the body's providential mechanism reserved for extremes, such as starvation. Were the brain able to ask you for nourishment, it would not be asking for ketones. More important, the brain cannot run solely on these molecules. It still requires no less than 30% of its energy from glucose.
Number 2, I don't know about using a continuous glucose monitor for people without diabetes. Blood glucose excursions up to 120 are normal for billions of healthy people around the world. What isn't normal for those healthy populations is high non-HDL cholesterol. And you can get that by flattening your glucose curves by eating high saturated fat foods in place of beans and fruit, for example. You'd never know it from your glucose monitor. In this paper, the average daily intake of saturated fat was 2 grams per 1,000 calories for the low-fat diet and 30 grams per 1,000 calories for the low-carb diet. I know, there are many other things you can learn from a glucose monitor to flatten the curve, like maybe eating more slowly and taking a walk after your meal. Number 3, there's been a very popular hypothesis for the last few decades that after you eat carbs, your insulin levels rise, and that triggers fat storage. In this study, we did indeed see insulin levels rise after a meal on the low-fat diet, but that was the diet that led to more fat burning over the 2 weeks. Ouch, Kevin caught me with a bad misstatement of facts here. It isn't that the low-carb group was burning less fat. They were actually burning more because they were eating more. It's just they were experiencing lower body fat loss. It doesn't seem to me that that hypothesis is aging well. I'll link to a few good papers about it in the description. But I agree with obesity researcher Stephan Guillenet and Kevin Hall. It's probably wrong. Was I being such a scientist to use the word probably? Well, then I'll have Daniel translate it into such a YouTuber language.
We've been lied to. Everything that has been told to us about food is wrong. Grandpa, can you please stop taking my glasses?
Kevin got some pushback from a few scientists who said it takes longer than 2 weeks to become fat adapted, and that could be somewhat true. But Kevin points out that ketone levels had pretty much leveled off, as had uric acid, which is also a decent marker. I actually think carb adaptation could take longer. It's starting to rain. Because digesting fiber takes a healthy microbiome, and there's a lot of wrecked microbiomes out there from taking antibiotics and years of eating a low-fiber diet. I really need to interview someone above my pay grade like Will Bolsowitz about that. The great news is once we are fiber adapted, this study shows we can get some really great blood work numbers, no? And number 5, and maybe most important, I think I speak for almost everyone who's read your papers, Kevin, we need a book from you where you can expand on this and write in consumer language, please. You see what I do for you, Kevin? I get myself soaked and frozen to ask you to write a book.